Hi, my name's Professor Stuart Wyithe. I'm a Laureate Fellow here in the University of Melbourne, and I'm Theme Leader for the Evolving Universe portion of the CAASTRO Science Program. So my research interests are in how the first galaxies formed within the first 10% or so of the universe's age, and how they, what they call reionization, whereby the hydrogen gas that pervades all of space was atomic and cold in early times, but once the first galaxies formed, the starlight from those galaxies ionized the gas surrounding them and heated it up to a much higher temperature. And this process is the process of reionization is the largest, or the largest event that's undergone the baryonic component of the universe, and it's one that's little understood. And so this is one of the major components of the evolving theme, is to try and use radio waves from this gas in the early universe to try and trace how galaxies first reionized the universe, and by extension when those galaxies formed, and other properties like their mass. So the aim is really to try and understand the different stages of the formation and evolution of galaxies from the first galaxies during the reionization era, but then following on to look at the formation of the first supermassive black holes in galaxies, and try and understand what the peak of the era when stars were most actively forming, about at redshift of about 2, so about 5 billion years ago, and try and understand why the universe is a much quieter place today than it was then, with much less stars forming and much less activity around the supermassive black holes. And so to try and get a picture of the formation and evolution of galaxies across the whole of cosmic time. And the engine for doing this, which CAASTRO is using, is the 21 centimeter emission line of hydrogen. And so in the reionization era, we can use that emission to trace the gas between the galaxies and its properties and its distribution. And at later times, we can use that 21 centimeter line to study hydrogen gas in the galaxies themselves, and by combining that with observations of the starlight through telescopes like SkyMapper, we can try and understand the process by which that gas that we see in the 21 centimeter line turned into stars, and try and really pin down all aspects of the life cycle of galaxies. So the theme is using 3 primary facilities. The first is the Murchison Wide Field Array in Western Australia, and this is a telescope that's been designed to study the emission line from this 21 centimeter emission line from hydrogen during the reionization era. And so this is the time within the first billion years of the universe's age, and the universe has expanded by a factor of about 10 since that time. And so the hydrogen emission line, which was originally at 21 centimeters, has redshifted out to a wavelength of about 2 meters. And so this needs a new class of telescope to try and observe this phenomenon. And so we're using the Murchison Wide Field Array to do that, and we're participating in its development. We're using the Australian SKA Pathfinder, ASCAP, which is currently being constructed by CSIRO. And we're involved in the major surveys that ASCAP will do to study the hydrogen gas in galaxies in the nearby universe and in the universe out to about a redshift of 0.5, through surveys called Wallaby and Dingo. And those are the biggest surveys of galaxies that will be done in the near future, and that they're being done by looking for the hydrogen gas in these galaxies. The other very important telescope is the SkyMapper telescope. SkyMapper will survey in optical light the whole southern sky, and by combining the observations of the stars that we get in the optical light with the gas that we get from the ASCAP surveys, we can really try and understand the interaction between the gas and the stars in galaxies. The Evolving Universe theme is broken up into several projects. Project on reionization. There's a project of simulations, which is to look at supercomputing simulations for first galaxies that formed during reionization and how they interacted with the universe around them. There's a projects to do with the ASCAP, Australian Escape Pathfinder surveys. One to look at with the Wallaby survey, which is a survey of galaxies across the southern sky. Postdocs working in the FLASH survey, which is a survey to look for hydrogen gas in galaxies in absorption against bright background sources. There's postdocs working on the SAMI instrument, which is a new multi-object IFU or integral field unit, which is going on the Australian Astronomical Telescope.